Imagine a grand library filled with countless books. To find a specific volume, you might use a system of coordinates. First, you note the shelf's row, stretching left and right. This is like our first dimension length. Next, you pinpoint the shelf's height from the ground. This is akin to our second dimension height. Finally, you consider the book's position on the shelf, front to back. This represents our third dimension, depth. These three dimensions define the space we experience every day. They dictate the size and position of every object we encounter. A teacup, for instance, occupies a specific region of space defined by its length, width, and height. We can easily visualize these three dimensions and understand how objects exist within them. But what if I told you there's more to our universe than these familiar dimensions? What if I told you there's a fourth dimension, one that's all around us, yet invisible to our eyes? This fourth dimension, my friends, is time itself. Time, unlike the spatial dimensions, is not something we can touch or see, yet we experience its passage every second of our lives. Time flows forward, carrying us along with it. We age, seasons change, and the universe itself evolves. This constant, relentless progression is the hallmark of time. Just as an object has a position in space, it also has a position in time. Think of a pocket watch, its hands ticking away the seconds. At this moment, you and I exist at a specific point in time. A moment ago, we were in the past. In a moment, we will be in the future. To fully describe an event, we need more than just its location in space. We also need to know it occurred. The chime of a clock, the fall of an apple, the twinkling of a star, all these events exist within the grand tapestry of space-time. In the early 20th century, a brilliant physicist named Albert Einstein revolutionized our understanding of the universe. He proposed that space and time are not separate entities, but rather two sides of the same coin. This unified concept is known as space-time. Imagine a flexible sheet, like a trampoline. This sheet represents the fabric of space-time. Objects with mass, like stars and planets, rest upon this fabric, causing it to sag or curve. This curvature, my friends, is the key to understanding gravity. Einstein's theory of general relativity describes this relationship between mass and space-time. It's a complex theory, but the basic idea is quite elegant. Gravity is not a force acting at a distance, but rather a consequence of the curvature of space-time. Section 4. A cosmic dent. Mass and the curvature of space-time. Think back to our trampoline analogy. A bowling ball placed in the center of the trampoline will create a significant dip. This dip represents the curvature of space-time caused by the bowling ball's mass. Now imagine rolling a marble across the trampoline. What happens? The marble, instead of traveling in a straight line, will curve inward towards the bowling ball. This is similar to how objects move in the presence of a large mass like a star or planet. The mass warps the fabric of space-time, and objects simply follow the curves. The greater the mass, the greater the curvature of space-time. This is why massive objects like black holes have such a powerful gravitational pull. They create incredibly deep gravity wells in the fabric of space-time, trapping anything that ventures too close. Section 5. Gravity's secret. A downward spiral through space-time. We often think of gravity as a force pulling us down. However, from the perspective of space-time, it's more accurate to say that we are simply following the curves in the fabric of reality. Just as a marble rolls towards the center of the trampoline, we are drawn towards the center of the Earth. The Earth, like all massive objects, creates a curvature in space-time. This curvature dictates the path of objects around it, including ourselves. When we jump, we are not being pulled down by an invisible force. Rather, We are following a curved path through space-time, created by the Earth's mass. This curvature of space-time is not limited to large objects like planets and stars. Even small objects like apples and teacups create their own tiny distortions in the fabric of reality. However, these distortions are so minuscule that they are practically imperceptible. Section 6. The dance of space and time. Einstein's theory of general relativity revolutionized our understanding of gravity and its relationship to space-time. It revealed that space and time are not independent entities, but rather intertwined aspects of a single, unified fabric. This fabric, like a cosmic dance floor, is constantly being warped and stretched by the objects within it. Massive objects create deep curves, influencing the motion of everything around them. Even the tiniest objects, like you and me, play a role in this cosmic dance, subtly influencing the fabric of space-time with our presence. As we continue to explore the universe, we gain a deeper appreciation for the profound interconnectedness of space and time. The universe is not a static stage upon which events unfold, but a dynamic and ever-evolving tapestry woven from the very fabric of reality itself.